Welcome to ICND2. My name's Terry Vincent. I'm the lead instructor for the routing and switching track here at IP Expert. That includes CCNA, CCNP, and CCIE. Now what we're doing here is we're in the second part of our video on demand series, which is going to be dealing with taking and securing the CCNA certification. And in the first part of our presentation, all of the classes were focused around a lot of theoretical components. Now, by virtue of the fact that we're now past that, we're going to take the information that we learned in ICND1 and we're going to see how it's applied in ICND2, and we're going to be expanding on it. Now, what that's going to translate to is that we're going to be the majority of our time is going to be spent here at the console, at the command line interface. So I'll bounce between the command line and this idea of a whiteboard where I'm going to have to be able to add or expound on theory that we currently already have. Now, the main focus right now is going to be dealing with everything related to how we're going to be expanding our network infrastructure. And the expansion of our network infrastructure is going to begin with an in-depth conversation about VLANs. VLANs, our virtual local area networks. Now, in the confines of a virtual local area network, what we really want to understand is that we have to recognize that there's a base operation with regard to how we create VLANs, how VLANs operate, and the fact that we can use individual VLANs to represent network segments. So notice that we're taking information from ICND1 and all we're going to be doing is applying it directly to the concept of ICND2. Now, in that context, what we want to realize is that we have basic characteristics that are associated with VLANs. So of those characteristics, we need to identify what they are. So the first primary characteristic that I want to put in here is the fact that when we set up VLANs, each VLAN represents an independent network. An independent network. So that's going to be representative of, say, an Ethernet segment or an IP address range or a network itself. So for every VLAN, what we're doing is we're going to be creating a broadcast domain. Now, we mentioned in ICND1 that we need methods by which we can send information from one VLAN to another, requiring things like layer 3 switching, independent connections to an individual device, or something that we refer to as router on a stick configuration. Now, the other part of this is that when we start looking at this, an independent network means exactly what I said before. We have a single broadcast domain. Now, the last element that I want to bring up here is going to be the fact that this is going to represent a logical network. So when we talk about the IP addresses or the addresses that we're going to be using, we're going to be focusing on IP addresses. And what we're going to do is we're going to use this entire concept here to be able to segment our network. And once our network is segmented, we can also apply security as well as the idea of enhancing network flexibility. So through the use of VLANs, we make our networks segmented, i.e. breaking them up into smaller domains, and we can also implement security, and we get the idea of this idea or this concept of network flexibility. Now, when we look at VLANs, VLANs are going to be relatively simple for us to deploy, and what we're going to find here is that we're going to do this the majority of the time on devices like switches. Now, what I want to do is I'm going to bring up my configuration that I have on my equipment here, and what I'll do is I'm going to actually expand on this and draw out a topology to illustrate what we have. In my current scenario, I have two switches, Cat1 connected to Cat2. And what I'm going to do is I'm simply going to bring these devices up. And what we're going to do is we're going to entertain this idea of VLANs. Now, in order to be able to do that, I'm going to access one of these devices. For instance, I'm going to access Cat1 in my scenario, in my situation. Now on Cat1, I may find myself in a situation where I want to be able to change the behavior of a given interface. Let's operate under assumption. On Cat 1, I have a physical connection between R1 and the catalyst switch itself. That's going to be on the interface on the switch of Fast Ethernet 01. So what I'm going to do is I'm going to go to the enable configuration. That's going to put me in my the privileged exec mode, and then I'm going to go to config T. And what I'll do is I'll go to the interface Fast Ethernet 01. Let's pretend that this interface is connected directly to my router R1. Now what I can do is I can come in here and I can specify the behavior of this interface. I can say switch port, and I can tell it what its mode is. I'll use context sensitive help, and what we're going to see here is the options that we actually have. Observe, we have access, we have .1Q tunnel, we have dynamic, private VLAN, and trunk. The two modes that we're going to be concerned with in the context of CCNA are going to be access and trunk. Trunk means I can carry multiple VLANs, ideally all of the VLANs that I have configured on this individual link, where access specifies that I'm only going to allow one. So in this scenario, what I'm going to do is I'm going to specify that my switch port mode is going to be access. Now that means this is now going to be able to carry information for one VLAN. But what is that VLAN? Well, that VLAN is going to be VLAN 1 by default. How do I know that? Well, one, I have the experience, and two, I know the show command that's going to reveal that process. I can come in here and say do show the idea of interface FA01 switch port. And what I'm going to see here is if I scroll back up, what I'm going to find here is it's going to tell me that my access mode VLAN is VLAN 1 by default. However, I can change that. I can change that by using another extension of the same set of commands I used before. I can say switch port, access, and I can define the VLAN that I'm going to use on this port. Let's say VLAN 20. Now what we're going to find here is in this scenario, VLAN 20 did not exist on this device. So what I'm going to do is that when I do this assignment under an individual interface, iOS is going to recognize it doesn't exist and it's going to create it. That's being typified by this output right here. The access VLAN does not exist, so we created that VLAN. Let's take a look at that. First of all, let's look in the confines of the switch port keyword that we used before. Do show interface Fast Ethernet 01 switch port, and what I'm going to find here is now my access mode is VLAN 20. Did VLAN 20 get created? Let's take a look at that. Show run pipe include VLAN. And what we're going to find here is oddly, I need to do the do. What we're going to find here is oddly, the only thing that we see here is going to be the configuration of the VLAN policy and the access VLAN. So if I want to see a VLAN and whether or not it's existed or assigned to an interface, the show command is going to be different than any of the show commands we've used to date. It's going to be show VLAN, and what I want to do is I'm going to execute the brief to get a summation of all of these different values that we're working with. What we're going to see right here is VLAN 20 does indeed exist. We also see that it's active, and it's going to be and has been assigned to Fast Ethernet 01. So once that's done, that means that this particular VLAN has been assigned under this particular interface. Now, if I did not want to do it this way, I have other options. I could have created a VLAN just using the configuration command itself. I could go config T and say, I want to create VLAN 60 and hit enter. Now, that VLAN has been configured. But if I come up here and say, do show VLAN brief, and I hit enter, what we're going to find here is I don't see it anywhere in my configuration. All I see is VLAN 20. And yet, I know I'm in VLAN configuration mode. Now, what we need to understand here is that before this VLAN can actually be created, we have to exit the process. So I'm going to say exit, and now if I do show VLAN brief, what we're going to find here is that this particular VLAN will now have been created. Now, the name, notice we have this idea here of name. So our VLAN 1 is our default VLAN. VLAN 20 automatically received the name of VLAN 0020. 60 received the same thing, 0060. Now we can modify that behavior. So we modify it by going into the VLAN process, so say VLAN 20, hit enter, and what I can do is I can execute the name command. And I'm going to say human resources. Hit enter. Now if I exit and do show VLAN brief, what I'm going to find here is that that name that I just assigned is going to be in the category of the name listing as human resources. So we've demonstrated everything that's part and parcel and responsible for allowing me to create VLANs. I've executed the show VLAN command so we can see what VLANs have been created. There's also another command that I can illustrate here, which is going to be the do show VLAN command in its own right, which is going to give me all of the information associated with my VLANs, to include VLANs that fall outside the scope of our conversations for CCNA. We will mention things like private VLANs, but we will also talk about remote VLANs. But these other VLANs that we see up here that are going to be VLANs 1001 all the way, or 1002 to 1004, they're going to be special reserve VLANs that we're not necessarily going to need to know about in the context of our studies for CCNA. Now, we also want to recognize the fact that I described two processes. Process one is that I can have an access link where I can specify one VLAN that I want to use to communicate. The other option would be to employ a trunk whereby I can take a link between two switches. Say, for instance, I had VLAN 10 and VLAN 20 and VLAN 60. When I create a connection down to R1, I could specify any one of these VLANs on that link, or I could create a special purpose link between the two switches that is going to be deemed a trunk. Now, a trunk port is going to be a link that carries VLANs, more than one VLAN, across an individual interface. Now, what ends up happening here is if we were to pretend that I had traffic from VLAN 10 was red, VLAN 20 was green, and VLAN 60 was blue, and I have my two different devices that I have connected, my Cat1 and my Cat2 switches, so Cat1 and Catalyst 2, and I have this special purpose link between these, what I'm going to do is I'm going to realize that I'm going to actually be sending red information, or VLANs N10. I'm also going to be on that same link be sending VLAN 20, and also on that same link I'm going to be sending information associated with my VLAN 60. So across this trunk, we're actually sending all of the VLANs that we have in our infrastructure. Let's explore that at the command line, because what's going to end up happening is this trunk is going to maintain the data's integrity. So 20 is not going to get mixed up with 10, it's not going to get mixed up with 60. Everything's going to be maintained. So if I want to have interoperability where I have VLAN blue here, which is going to be 60, connected to a VLAN on this side, and I wanted to be able to have reachability across this trunk, what's going to end up happening is the trunk is going to give me the capability of having that value where I can reach between these different devices. So if this device were R1 and this device were R2, I could be ping between these two devices because they're actually in the same VLAN, and we rely on the trunk to carry all VLAN traffic between our switches. And that gives me the ability to be able to cascade switches throughout my topology and throughout my infrastructure. So again, looking at this, what we see here is that a trunk carries traffic for multiple VLANs. Now the question is at the command line, how do I configure a trunk? Well, let's bring up our devices. What we're going to see here is first of all, I'm going to default the configuration on both of these routers. I'm going to say default interface range FA0, 1, 2, 24. I'm going to do it on both Cat1 and on Cat2. Config T, I'm going to say default interface range FA0, 1, 2, 24. Now all I did was I took the device and put it back to its factory default configuration based on the iOS operation that we have going on right now. And we can see these links went down and these links came back up because their state changed. So let's look at what's happening here. Do we have any trunks? Well, I can see if I have trunks by going to R1 and executing a command. That command is going to be show interface trunk, T-R-U-N-K. Now, executing this command, I see immediately that I have negotiated trunk links between these devices. Now, I see I've negotiated a special kind of trunk link called a .1Q trunk. That means I'm using an industry standard negotiation protocol. But what I want to do is I want to find out why. So let's look at what's happening here under the configuration itself. So if I go in here and say I want to look at one of these trunks that actually got negotiated, show run interface FAO 19. And look what our configuration here is. Our configuration says that our interface configuration is just plain, vanilla. Well, let's go and look at another one. Let's do a show run. And what we're going to do is I'm going to say begin at interface fast Ethernet. And let's see what we see here. Notice 1 through 24 gives me no additional information. I have no config on this particular device whatsoever. Let's cut over to Cat2 and do the same thing. Only I'm going to just do show run here. I'm not going to use any filters. So let's see what we have on our individual interfaces. On the loopbacks, we still have config, but on Fast Ethernet 01 all the way down to 24, we don't have any configuration. So let's take a look at what our normal operation is on these links. Let's pick one. Let's say show CDP neighbor and see what we're connected to via Cat1. So we see we have 3 connections here to reach Cat1 on this device. They include Gigabit Ethernet 01, 24, and 23, connected to 23 and 24 on the other side. You can't see that because of my big body here. So 23 is connected to 23, 24 is connected to 24. This is the connection between Cat2 and Cat3. So, I mean Cat1. So when we execute this, I want to say show interface fast Ethernet 023 switch port. And what I want to do is I want to look at my basic settings. So when we scroll up here just a little bit, notice switch port is enabled. My mode is dynamic auto. My operational status, excuse me here, one moment, is going to be dynamic access. So right here, my operational mode is static access, not dynamic. Static access. So when I come over here and I execute the command show interface trunk, what I should see here is that notice I have no entry here for ports 23 and 24. So what I'm going to do is, just to make this easy, I'm going to go in and shut down ports 19 to 22. I'll do that simply enough. I'll say config T, I'll say interface range FA0 19 to 22, shut. Now it's going to give me some output here on this device, and it's also going to give me some additional output here on Cat1 when the time comes. But notice here, show interface trunk. See what we have here. We have the same link, so I'm going to do the same thing. Config T, interface range FA0 19 to 22, shut. Now let's look at the output of the show interface trunk command and see what we see. So there's our interfaces coming down finally, and we say show interface trunk so we can look at the nature of our trunks. We have no trunks. Now right now we have 2 links connecting Cat1 to Cat2. Those links are going to include 23 and 24. So all I want to do is I want to do a configuration where I create a trunk. I'm going to say config T, I'm going to say interface range FA0 23 to 24. I'm going to come in here, and rather than specify switch port mode access, what I'm going to do is I'm going to say switch port mode trunk. Let's look at that. I'm going to come in here and say switch port mode, and the specified mode is going to be trunk. Now what we're going to find is the system is going to argue with us. It's going to give us some information, because the idea is I'm trying to hardwire it to be a trunk, but I'm saying that I want you to use dynamic negotiation to determine what type of trunk we're going to perform. In other words, what type of encapsulation we're going to use. When we look at this, what this really translates to is we have 2 modes of encapsulation. We have .1Q, and we also have ISL. ISL being Cisco proprietary, like I mentioned in the previous lessons in ICND1, and it is falling out of favor, and .1Q is going to be normally our go-to method of choice to be able to implement this type of configuration. So looking at this, what we want to do is we want to make certain that we do the configuration the proper way, which means I need to, if I'm going to manually specify the trunking mode, I need to manually specify the encapsulation that I'm going to use. I'm going to specify .1Q. and it's going to look like this on my configuration. So under this interface, I'm going to say switch port mode trunk, but I can't do that yet. So what I'm going to do is I'm going to say switch port trunk encapsulation, and now what we're going to see is I have ISL and I have negotiate, and I have .1Q. So .1Q is the one that I want to use. So I'm going to specify .1Q and press enter. Now that I have manually specified the encapsulation type, I can come in here and say the other command, which is going to be switch port mode trunk. It's going to take the command. Now, interestingly enough, when we go over here, do show interface trunk, what we're going to see is that the system says that we are performing trunking, and it has been manually configured. So it says we're trunking and we're using .1Q. The problem here is the fact that this is exceedingly misleading. It's misleading because the thing that we have to recognize here is the commands that we use to be able to show the status of a trunk or a device are only indicative of the configuration on the side where the show command is implemented. This tells me, or would lead me to believe, that by virtue of the fact that I have these two values right here, that if I went over to cat2, I should have a trunk formed between cat1 and cat2. And what we're going to find is that's not the case. How do I know that? Show interface trunk. Now, we have 23 and 24, but notice that we have this connection where they did come up automatically. And the reason that they come up automatically was through negotiation. So one side set up for .1Q via hard coding. This side is set up for .1Q via negotiation. This is going to be using a protocol referred to as DTP. Let me get myself out of the way here. DTP, Dynamic Trunking Protocol. Dynamic Trunking Protocol is a protocol that we can use to auto-negotiate these links. Now, if I were to go to this interface and remove DTP, what we would find is that it's going to cause a problem in the config. So let's do that. And how do I remove Dynamic Trunking Protocol? Well, I have two ways that I could do it. Interface FAO or interface range. FA0, 23 to 24. I could come in here and say switch port mode access, which is going to turn off our DTP, but it's also going to take me out of trunking mode, so that's not something that I want to do. So what I'm going to say here is I'm going to say no switch port, or switch port no negotiate. Switch port no negotiate, sorry. Now the moment that I do that, what I realize here is I have another problem. I'm telling it not to use negotiation, but my default operation is dynamic communication. So when we go through here, what we're going to find is that this is going to have to, again, require me to change my mode. So if I come in here and say switch port mode, and I want to look at my trunking mode, one of my options here was dynamic. So I could come in here and say switch port mode dynamic, auto or desirable. Auto means that I want to form my trunk, but I'm not going to initiate the process. Dynamic means that I'm going to. Or I want to come in here and disable this process. I'm just going to say simply switch port mode trunk, but again, it's going to argue at me because of the fact that I need to specify my encapsulation. Switch port trunk encap.1Q. Now what I can come in here and is I can specify switch port no negotiate. But it's still going to bark at me. Why? Because of my dynamic status. Why? Because I only specified the encapsulation to use. I haven't said that you need to be a trunk. I'm going to say switch port mode trunk now. It's going to accept that command. Now that I've taken myself out of dynamic and put myself into static trunk mode, I can come in here and say switch port no negotiate, and I can disable that feature. Now the result of this is going to be do show interface trunk. And what are we going to see? Now we're going to see the ends have disappeared, and all we see is the fact that we have our link up and operational. So don't make the assertion that a show command is going to give you information about the distant end of the link. The show command is only going to be relative to the local configuration of the device where you're executing the show command. So do not get confused with that, because it can cause you huge problems down the line. Now also, like I said, we had the capability of executing different commands. One of the commands that I implemented, let me make sure that I've got access here. let's go end, was that show interface fast Ethernet 23 switch port command, which gave me the information about my switch port configuration. Now another command that I could actually use here is to show interfaces fast Ethernet 023 trunk. By specifying this, this is going to give me the information associated with my trunk. On this particular interface, we're doing .1Q, we're trunking. Our native VLAN is VLAN 1, and the trunks that are allowed on this link will be 1 through 4094. Now what we also see here is that of the VLANs that we have configured, every one of them is allowed on this link. So we've got VLAN 1, VLAN 123, and VLAN 236. Now what we notice here is if I come over here to Cat 1 and execute the same command, exit, show interface fast Ethernet 23 trunk, what I'm going to see, show interface, show interface fast Ethernet 023 trunk. What I'm going to see here is I have different VLANs. Now this is a problem because right now the only VLAN that's going to be sent across this link that's going to mean anything is going to be VLAN 1, my default VLAN. So again, all this does is just verify the trunking that has been configured in my infrastructure. But this begs the question. We took the system out of this idea of default negotiation mode. So in other words, we turned off DTP and we hard-coded the type of trunk that we wanted to negotiate. But what ended up happening is what would happen if we decided to leave that? What operational modes are there that we need to know about with regard to how we can do our configuration? Well, remember, we set this up using a couple of methods. So first of all, we need to recognize we have 4 modes. We have dynamic. Now, of our dynamic modes, we have dynamic auto, we have dynamic desirable, we have trunk, and we have access. We also have the repeat of these same 4 modes. So we have auto, desirable, trunk, and access. Now what we're going to do is we're going to draw a matrix of the different modes that we can have between each of these individual devices. Actually, this should be not there, so let me just erase that real quick. So we got dynamic auto, dynamic desirable, trunk, and access. So those are our 4 columns. So when we have this idea of dynamic auto and dynamic auto together, what we're going to end up with is an access trunk or an access link. The reason being is that, remember, dynamic auto wants to form a trunk, but it's not going to initiate the process. So that's going to be very, very problematic for us. Now, when we go in and we do auto to desirable, what we're going to end up with is we're going to, let me use a different color here, we're going to end up with a trunk. So if I have auto to trunk, I'm going to end up with a trunk. If I have auto to access, I'm going to end up with an access port. So when we repeat this process, what we're going to find here is that we're going to have circumstances where we're going to have access trunks or access, and we're going to have trunks. So if I have desirable to auto, I'm going to have a trunk. Desirable to desirable, it's going to create a trunk. Desirable to trunk, it's going to create a trunk. Desirable to access, what's going to end up happening is it's going to negotiate access. So repeating this exact process, what we're going to find here is we're going to have trunk, we're going to have trunk, we're going to have trunk. Now when we have trunk to access, what we're going to have is a special circumstance where we have what's referred to as limited connectivity. That can cause us major problems and we need to be aware of it. Remember, we mentioned the fact that for a lot of these features we need full duplex operation. So if these values don't agree, maybe we could have some other impacts on our infrastructure that can cause us problems. Also, when we look at the idea of access to dynamic, we're going to have access, Access to dynamic desirable is going to be access. Access to trunk is going to be the same here, so it's going to be limited connectivity. And lastly, we're going to have access if it's access on both sides. So bearing in mind, these are going to be the values that we need to keep track of in order to determine what's happening. And all of this is enabled on the basis of the fact that we have the idea of manual configuration, or we have the idea of this auto negotiation. So the auto negotiation process. And we interviewed all of the opportunities and possibilities that we have in order to be able to go in and disable any of those particular components. Now, looking at this also, again, we're going to constantly bring up the fact that no plan is going to be exact and nothing is going to work forever. So the moment that we understand what's involved here, we have to recognize that we also need to know how to troubleshoot issues. Troubleshooting is going to become something we're constantly talking about, because if you prepare for troubleshooting at the CCNA level, you'll be ready for it at the CCNP. So ultimately, when you hit the real world, or you decide that you want to entertain maybe taking the CCIE exam, what's going to happen is you're going to be very, very well prepared to be able to satisfy one of the sections of that exam, which is going to be troubleshooting. So it's devoted purely to the idea of doing troubleshooting. So when we go through here, what we need to recognize first and foremost is that we have our capability of having problems. So what I'm going to do is I'm going to draw a shape here. I'm going to draw a square. My problem may be that I have issues trying to connect. So I wanted to try to shrink this, but it's obviously not going to let me. So the idea here is that I have no connections. I have no connections for my VLANs. Now, recognizing that I don't have any connections, what I have to do is understand that I can do some types of troubleshooting. So some of the show commands that I may use here are going to be things like show VLAN. We already saw that output. I may come in here and do things like show MAC address table. Now, when we look at these commands, what we're going to say is now we have a decision block that we have to look at. And that's going to say basically, is the port in the right VLAN? So if the port's in the right VLAN, then we need to move on into our troubleshooting. But if the port is not in the right VLAN, what's going to end up happening is we're going to have to change its assignment and re-verify. Now, if it is in the VLAN, so if it's yes, if the port is in the proper VLAN, what we have to recognize now is we need to understand or recognize whether or not that VLAN is in the VLAN database. So is that VLAN in the database, in the DB? If it's not in the database, obviously what we're going to have to do is we're going to have to add it to the database, and then we're going to have to refresh our troubleshooting process. Lastly, what we're going to do is we're going to see, well, if it is, then obviously the issue is that we have to have some type of connection in the infrastructure, so it's possibly going to be PC related. But the main thing that I want to understand here is that to verify that it's in the database, what commands can I enter? Well, I can enter the exact command I entered before. I can type show VLAN. I could use show VLAN brief. I could type show interface. I could also type show interface with the switch port option. So again, keeping in mind that we have lots of different capabilities and lots of different features, but what I want to do is I want to review some of these commands on the actual equipment. So let's bring back up our rack, and what I'm going to do is I'm going to go to SW1 or CAT1, and I'm going to execute one of these commands. The one that I want to implement is first of all, the show VLAN. Show VLAN. We've seen this, absolutely nothing special. It gives us all the detailed information. We can say show VLAN brief. If we just want to see the snippets of information associated with the VLANs that are actually assigned, none of the information about any of the special VLANs appear in this output other than 1002 to 1005, which are going to be those reserved VLANs that we see right here. Now, recognizing that this happens, another command that I said that we could use is the show MAC address. What is it? Let's see, show MAC address table. And this is going to give me a list of the MAC addresses that have been learned on all of my interfaces and whether or not they've been statically configured or dynamically configured. So this is going to allow me to determine whether or not a port is in the proper VLAN. I can determine based on its port number in the show VLAN or the VLAN brief, or I can use the MAC address if I know what the MAC address is by looking at the address table. Now the other part of this means that when we boil this all down, what we need to realize here is we have the capability of doing this idea of troubleshooting our VLANs, but VLAN troubleshooting is not the only thing that we need to be concerned with. One of our other requirements may be to actually troubleshoot our trunks. So if I want to troubleshoot a trunk, what's my flow process? I'll go ahead and take my big old head out of the way so I don't run into that issue before, like I did before, and I'll just manually draw everything right now. So what I'm going to do is I'm going to troubleshoot links. Troubleshoot trunk links. So my trunks. So in order to be able to do that, what I need to do is I need to ask myself the first question. The first question is the local and peer VLAN set up properly? So is the local and peer native VLAN the same? Now what's that mean? Well, let's cut over to our configuration here and I'm going to show you exactly what it means. When I come up and I say show interface trunk here, what I'm going to see is I haven't negotiated a .1Q trunk, and notice it's telling me my native VLAN is 1. Now, if I want to modify that behavior, I can come up here and say interface, interface range, fast Ethernet 23 to 24. And what I'm going to do is I'm going to say switch port trunk. And what I'm going to say is I'm going to say native. And now what I can do is I can specify a VLAN, let's say 20. Now, the moment I do this, what happens now is we're going to see I'm going to begin getting all kinds of messages that are going to tell me that I have a mismatch in my configuration that says the native VLANs don't match. So what is the native VLAN? Well, in the context of ISL, there is no native VLAN. Even though the system is going to tell you, it's going to say that native VLAN 1, ISL has no native VLAN. Everything is tagged. In the context of .1Q trunk links, what we're going to find is that the native VLAN is going to be a VLAN that has absolutely no tagging on it. One of the rationales behind having this is so that I can take it possibly like a telephone and connect it to my infrastructure and have a PC connected to that phone. Because remember, phones have little 3-port switches in them traditionally. And what's going to end up happening is the tag traffic is going to go to the voice VLAN, the untagged traffic is going to go to the native VLAN, and it's going to allow that single cable to be a trunk basically for 2 VLANs. Now looking at this, what we're going to see is we're going to get this idea here of native VLAN mismatch, and look what the protocol is that's going to inform us about this. Now I've got 2 options at this particular juncture. I could fix this problem and make the native VLAN match on both sides of the link, or I could simply come over here and say I wanted to disable CDP. Well, obviously I don't want to disable CDP. I want it to actually work. So I'm going to say no switch port trunk native VLAN. What's going to end up happening is everything should come back up and be operational, and that should have removed that configuration. So do show interface trunk. What am I going to find? I'm going to find that my native VLANs are all 1, and now everything's going to start unblocking. Because the situation that I'm describing here is in instances where my native VLANs do not match, what we're going to find is that the configuration is going to block traffic. It's going to affect something called spanning tree, a protocol we haven't really talked about yet. So the idea here is if they're in the same if they're not configured properly, then what we're going to have to do is we're going to have to change the native VLAN. And obviously retest. But what if they are in the same configuration? Well, that moves us back over to our next logical block. So the main thing here is if I want to know about these VLANs and whether or not they're configured properly with regard to the proper native VLAN, the command that I used in my example was show interface trunk. Another command that I'm going to use is going to be the exact same command over here, show interface trunk. Because what I want to do right now is I want to find out if we're in the right modes. So are the local and the remote switch in the correct trunk mode. Obviously, if they're not, we're going to have to configure it. Typically, we're going to configure it statically to fix this issue. Once that's done, then obviously we're going to retest. If they are in the same operational mode, then obviously this is telling us that we have an operational trunk. So keeping in mind the fact that this is going to be the relevant process, again, all I want to do is go through and review some of the commands that we're going to implement or execute in order to be able to do these verifications. So again, one of the commands is going to be show interface fast Ethernet 023, and I'm going to say trunk. And that's going to give me the information associated with that. Now notice in here that I have this idea of being able to see what's connected. So I'm looking at this particular port right here. It's telling me that its mode is on in this instance. It's going to tell me that I've negotiated my trunk. I am trunking. This is my native VLAN. So we can see all of the information relevant to our troubleshooting process in that one particular set of commands. So these commands are definitely something that we're going to be doing, and I'm going to continue my illustrations here on the equipment and on the whiteboard because it's going to allow us to be able to see everything that we're talking about, because in ICND2, theory is considered to be already in our brains. We're already ready to go with it. So what we're going to do is we're going to explore each of these concepts on the console, and we're going to just draw everything out as we go. So with that being said, what we're going to do is this wraps up our conversation about the initial introductions to these VLANs, and what we're going to do is we're going to return in the next lesson, and I'll see you there. Bye-bye.